This short video is going to be on adding fractions with unlike denominators. So on the screen you can see 5 steps for how to add fractions. We're always going to be writing these problems up and down or vertical because that helps us when we have to get common denominators, which is the second step. So in order to get the common denominators, we're going to apply what we've learned last unit with calculating the least common multiple. As I work through a problem with you, you're going to hear this phrase often: what you do to one side, you have to do to the other. So please keep that in mind. After you have common denominators, you're going to add the fractions. If it's a mixed number, you're then going to add the whole numbers. And as always, we must simplify our fractions. So here comes our first problem. You guys can just pay attention, follow along. So our fraction is going to be 3/8 plus 2/4. If you're analyzing the denominators, they're not the same. One is an 8, one is a 4, so we have to get common denominators. So what we're going to do first is draw some arrows, set up our problem with fraction bars and a plus sign. And now it's time to calculate the least common multiple of 8 and 4. So you're going to ask yourself, what number can 8 and 4 go into? Also known as the LCM of 8 and 4. Yes, your answer should be 8. You could always use numbers such as 16, 24, and there's many other options, but we prefer the smallest one so that there's less work to do in the end. Here comes that common phrase. We're going to take a look at the first fraction. Since the denominator did not change, it's as if we multiplied the denominators by 1. 8 times 1 is itself. What you do to one side, you have to do to the other. So 3 times 1 would be 3. Applying the same method, but with different numbers to the bottom, we changed the 4 to an 8. So in order to get there, you had to multiply by 2. What you do to the bottom, you have to do to the top to keep them equivalent. 2 times 2 is 4, so now that we have common denominators with equivalent fractions, we can now add these fractions because they are like fractions, which means they have the same number in the denominator. So 3/8 plus 4/8 would be 7/8. The denominator will not change. You add the numerators. 3 plus 4 is 7. Thanks for listening, and I hope that helped. Hey there! We are now going to learn how to add mixed numbers with regrouping. So we're going to apply the same steps, always writing our addition of fraction problems vertically. We have to have common denominators, so we're going to use the LCM. We're going to continue to use that famous phrase, what you do to one side, you have to do to the other to keep our fractions equivalent. And then we're always going to start with our fractions before we add our whole numbers. Let's take a look at what our problem is going to be. So our first fraction is going to be 5 3/8, and we're going to add that to 3/4. So one issue I see is that they don't have common denominators. So from that first video, let's use our arrows and rewrite everything. So the big number 5 is not going to change, the plus sign won't change, but our fractions may change. So if our denominators are 8 and 4, we want to think of the smallest number that 8 and 4 can go into. So the LCM of 8 and 4 is 8. Now it comes time for the equivalent fraction part. So looking at the top number, the denominator did not change. So 8 times 1 is still 8. What you do to the bottom, you have to do to the top. So 3 times 1 is 3, which makes sense. If the denominator doesn't change, the numerator should not change either. With the second fraction, the 4 became an 8. So it did get larger, which means we have to multiply, and we multiplied it by 2. So we're going to rewrite that shortcut from the bottom to the top. So 3 times 2 is 6. Okay? So now that we've got common denominators of 8, we're going to start by adding the fractions first. For now, we're going to ignore that whole number of 5. So here we go. If I can get this to be blue. Oh, black or yellow will work. So adding the numerators, 3 plus 6 is 9. Our denominator will stay in 8. And now that we added our fractions, let's go ahead and add the whole numbers. Well, thankfully, there's only a 5, and there's nothing in front of the second fraction to add to 5, so we're just going to keep it 5. It's almost like we did 5 plus 0 is 5. However, if you're analyzing that final answer, something looks different. We can't have an improper fraction within our mixed number. So we're going to analyze this 9/8 and convert it into a mixed number. So if you recall how to do that, 8 goes into 9 one whole time. Because I said one whole, I need to combine that plus 1 with our whole number of 5. What's left over after 8 goes into 9 one whole time? You're right, there should be 1 left over, and our denominator will never change. So now to kind of regroup and add together our whole numbers, 1 plus 5 is 6. So because that's a little sloppy, let me try rewriting our final answer off to the side. We're going to have 6 and 1/8. So to recap, after you get common denominators and an answer, if you have an improper fraction within your final answer, you have to regroup so that you changed your whole number to one larger whole number. You might even have to add 2 at some point. It depends on the problem. So hopefully that helps, and go ahead and try some on your own. Hey there, it is time to learn how to subtract fractions with unlike denominators. So it's still the same steps as before with addition of fractions. We're going to rewrite the problem vertically. We have to have common denominators. Then instead of adding, we're going to be subtracting the fractions, followed up by subtracting any whole numbers if there's mixed numbers, and we always end the problem by simplifying. So the problem we're going to work with is 6 3/4 minus 4 1/2. As you can tell, we do not have common denominators, so that is our first goal. So I'm going to draw our arrows because we're about to convert these into equivalent fractions. Our whole numbers can't change though, so I'm just rewriting everything else with our equal sign. And now analyze our denominators. It used to be 4 and 2, so what is the LCM of 4 and 2? The smallest number that 4 and 2 can go into. Hopefully you're thinking 4. If you just multiply them together to get 8, that would work, but you're going to create a lot more work at the end. So I'm going to use the LCM. Keeping in mind what you do to one side, you have to do to the other. So since the top number never changed with their denominators, the numerator is not going to change either. We're going to have to do a little bit of work for this bottom one because the 2 became a 4. So 2 times what is 4? Well, it's 2. So what you do to the bottom, you do to the top, and 1 times 2 is 2. Now it looks like we're ready to subtract, and so let's subtract our fractions. Don't worry about the whole numbers yet. 3/4 minus 2/4 is 1/4. Now we can go to our whole numbers. 6 minus 4 is 2, and that's it. So we still have to have common denominators. Start with the fractions for subtracting, then do your whole numbers, and you'll get your final answer. Thankfully, we don't have to simplify for this problem, so enjoy the rest of your day. Hi, it is time for our last video on subtraction. So what I'm going to do is I'm going to show you a problem, and then we're going to solve a different one, just so you can get a glimpse of what we're about to do. So I have a problem that's already written vertically, 2 1/4 minus 1 3/4. The good news is they already have common denominators and they're set up vertically. The bad news is if you're to go ahead and start subtracting the fractions, you can't do 1 minus 3. You would get a negative number, so we can't take 3 away from 1. So the common phrase for these types of subtraction problems is if the bottom number is bigger, you need to borrow, just like what we did with whole numbers. So the problem that we're going to work with from start to finish is 8 1/3 minus 2 3/4. This one we're going to have a couple issues because if you're looking at the denominators, they're not the same. So we have to get common denominators first. So I'm going to draw my arrows, rewrite the whole numbers, get everything set up. And now it's time to think. What number can 3 and 4 go into? What's the LCM of 3 and 4? Hopefully you're thinking 12. You could always use 24. There's a couple options, but again, we want the smallest number so it's less work to do later on with the simplifying. Both of these denominators changed, so we're going to have to do a couple different conversions. So let's start with the top one. 3 times what is 12? Exactly, it's 4. So what you do to the bottom, you do to the top. 1 times 4 is 4. For the bottom fraction, 4 became a 12, so we multiplied it by 3. What you do to the bottom, you do to the top. 3 times 3 is 9. So now we've got our problem set up vertically. We have common denominators. We're so close to being able to subtract, but when you get to the subtracting of fractions, it says 4 minus 9, which we can't do. You would get a negative answer. So what I'm going to do is I'm going to rewrite this problem on another slide and show you how to borrow. So we're going to write down 8 4/12 minus 2 9/12. All right, the bottom number is bigger, you need to borrow. So here comes the borrowing. We are only going to mess with that top mixed number, 8 4/12. And just like with regular subtraction, you're going to borrow from the place value to the left. So 1 less than 8 is 7. The only difference is we're not just going to add on 10 to the number 4. If we thought about this problem as pizzas, remember when we had 8 whole pizzas and 4/12 of another? Well, this denominator is the most important number. That tells you how many equal-sized slices your pizza is cut into. So now when I just took away 1 whole pizza from the 8 and I made it a 7, it's as if I'm adding on a whole pizza, remember how it's cut into 12 slices, to the 4 slices that I already have. To summarize, whatever your denominator is, that's the number that you're going to add on to your numerator before you do any subtraction. I think you'd agree this looks messy, so I'm going to rewrite it as 7 16/12. And then we never touch that second fraction, so that makes it nice. So one more time, when it wasn't 8 4/12, I took away 1 from the 8 and made it a 7, and we added on the denominator to our numerator to get 4 plus 12, which is 16. Now they're written vertically. We have common denominators. The top numerator is larger, so we're able to subtract. Here we go. 16 minus 9 is 7. The denominator will not change. We can do our whole numbers now. 7 minus 2 is 5. Check for simplifying, but we can't simplify, so that is our final answer. This is the trickiest problem, so if you have questions, please let a classmate know or the teacher. Thank you.